Today, let me welcome you all for the inverse Z transform sessions of mine, which is coming under video syllabus, and it is studied by 4th ECE students under module 5. This inverse Z transform and non-inverse Z transforms, this is a topic any students can study, whichever the branch or whichever the students, disciplined students, even other than non-engineering students also, right, they can study. They can understand how the transformations, Z transformations and inverse Z transform sequence, right, can be done, can be analyzed, right. This is not specific to only 4th ECE students. Anybody interested who can do projects, seminars, MTech thesis or PhD, right, students can study this, right. Now, in my all previous session, this is a continuation sessions of my all previous 8 lectures. This is lecture number 9, right. Now, in all my previous sessions, I explained, we discussed about the Z transform of sequence, Z transform of any sequence, any input sequence, that is time domain sequence, discrete time sequence, and we discussed applications of Z transforms and how this Z transform is different from other transforms like Fourier transforms, Laplace transforms we studied, and we have solved problems X of n, simple problem how to get Z transform of any simple sequence we have seen, and a complex sequence in the analysis signal processing we see, and also we plotted power poles and zeros in the Z domain, and we studied ROC, region of convergence, where exactly it converges, X of n converges, that and all we see, and we have compared, analyzed better, and later we studied properties also, 7 to 8 beautiful properties we studied, and using those properties, how we solve the transform we studied, right, in faster way. Then last class we studied inverse Z transform, that is, after processing any signals into X of Z, Z transformations, analyzed, everything done, then how to get back original sequence back, right, whatever the signals which is given, to get back, we went for inverse Z transform. That is the topic of today. Inverse Z transforms is nothing but getting back our original signals from the processed Z transformed sequence signals, right? That's what we are doing. And last class we have seen that in the inverse Z transforms, there exist two types of right, inverse Z transforms we have done, getting back original signals. That's what one is, partial fractions expansions method. Partial fractions expansions method, which is like maths only. And the other is power series expansions method. Power series expansions method. In that, we have discussed partial fractions expansions method, where X of Z sequence, ratio of polynomials we are getting at X of Z, no? If m is greater than n, we study, m less than n, conditions 1. Then direct partials fractions method, which we have discussed last class. And the next class, now this class what we will do is, m, when m is m numerator is equal to or greater than n, then partial fractions expansions is being done by using long divisions method, which we discussed. Long divisions method. Then we will get our original sequence X of n using long divisions method. When m is equal to n, for example, m is 2, and n is 2. We have done last class. Today we will deal when m is greater than n. Today we will deal this, right? Today's topic is in a complex sequence, transform sequence X of Z. If the Z power, numerator power is greater than n, that means m is 3, n is 2. Then how to solve such complex, how to get back original signals X of n from such complex signals, we'll see through one example, right? Today's topic is this. These two is done previously, right? Now, let me write that, let me see one problem like that. Find inverse Z transform of X of Z is equal to one complex processed right, Z transform sequence is ratio of z power 3 plus z power 2 plus z power plus 3 by 2 z plus 1 by 2. That is numerator. The denominator is z power 3 maximum plus 3 by 2 z square plus 1 by 2 z. R was is giving, R was is less than 1 by 2. This is the problem is giving. This is the problem is giving. What is that? For example, by seeing the problem, we will understand. Problem is very simple, right? Only we should understand initial lines. For example, R is less than 1 by 2 is given. Then what is the meaning? It is left-sided sequence. It is left-sided sequence, right? U of minus n minus 1 you will get. Left-sided sequence. Left half of the sequence you will get. U of minus n. Generally we start from minus 1. U of minus n minus 1 you will get. That is the first look you will understand. Then see numerator and denominator. Then by partial fractions expansion method he says. But he is not telling which method, long divisions method or this direct partial fractions expansion method. He will not tell. You have to see now. Now what you should do? The problem is this. Now the solution is very simple. First write x of z is equal to whatever given. Z2 plus z square plus 3 by 2 z plus 1 by 2 plus y z cube plus 3 by 2 z square plus 1 by 2 z. Now immediately see the maximum powers of z. See that numerator and denominator. See the maximum powers of z. Maximum powers of z is 3. See that? Multiply and divide immediately. Whenever you get, instead of z power minus 1 normally, minus 2, minus 3, if you get z power of plus, then you should always, for simplification purpose, multiply and divide by maximum z power minus maximum. Here z power minus 3. You have to multiply and divide. Right? Now I will do that one. For example, I will do that one. Now let's see. See, multiply and divide by z power minus 3. Then what I will get is x of z is equal to z power minus 3, z power minus 3 into numerator and denominator as usual. Now simplify that. Now you will get right side is equal to z power minus 3 to z power 3 is z power 0. Z power 0 is minimum 1 plus z power minus 3 to z power 2 is z power minus 1 plus z power minus 3 into 3 by 2 z is 3 by 2 z power minus 1. Similarly, last one 1 by 2 z power minus 3. Similarly, denominator z power minus 3 to z power 3 is 1 plus 3 by 2 z power minus 1 plus 1 by 2 into z power minus 2. Like this, you will get numerator, denominator after simplification. If it is plus z powers, then you have to get it in terms of z power minus only. Now, observe maximum power of m and n. Now, by looking this equation, this is our normal problem like our previous. Now, see, m is 3 here. In this case, m is 3. See, z power minus 3 is there. N is minus 2 is there. Therefore, n is 3, n is 2. That means m is greater than n. Then we have to do long divisions method to get your original function. To get your original signals, you have to go for long divisions method. Already we have done this method we know. What you should do? Take device as denominator, write it as device. Take numerator, write it as denominator. For example, in this case, see this division is this. Right from this side, 1 by 2 z power minus 2, 3 by 2 z power minus 1 plus 1. Write it as divisor. See this? I have written it as division. See this? This is division, right? Then numerator as dividend, right? For example, what is numerator? Numerator is this. Z 1 by 2 z power minus 3 plus 3 by 2 z power minus 2 plus z power minus 1 plus 2. Write that as, right? For example, here that is divisor. Dividend. Now start dividing like your normal divisions. What you get? Till you get this term gets cancelled. For example, see this first term. I should get first term also like this. Such a way you do multiplications with this dividend. Now, for example, 1 by 2 z power minus 3 is here. 1 by 2 z power minus 2 is here. Then see this, which one you have to see? Multiply. For example, z power minus 1 if I multiply, see this gets cancelled. Z power minus 1 into z power minus 2 is z power minus 3. 1 by 2 into 1 is nothing but 1 by 2. Therefore, this gets cancelled when you multiply, you subtract. Now, similarly, multiply this with all others. Z power minus 1 into 3 by 2 z power minus 2 is 3 by 2 z power minus 2. Z power minus 1 into 1 is Z power minus 1. Now start subtracting. This gets cancelled. This gets cancelled. This gets cancelled. So left with plus 1. Now it is simple. Stop divisions. Now take this right remainder, right x of z. X of z is equal to this quotient first. Z inverse plus this remainder as numerator. Then by this division as denominator. Call this as x1z. X of z is equal to z inverse plus 1 by this. Now this is nothing but x1z now. This is coming to your normal form now. See, z power m is less than n. For example, n is 2 powers, m is 0. Therefore, this is our normal form x1z. Now take this one outside and do the x1, x2 calculate. Sorry, k1, k2 you calculate now, like as usual. Now take out that x1z. x1z is equal to 1 by that, right? 1 plus 3 by 2 z inverse plus 1 by 2 z inverse 2. Then write partial fractions normal method, direct method. 1 by, neglect this numerator. Now write this in terms of the factorization. 1 plus z inverse plus into 1 plus 1 by 2 z inverse. Now see, 1 into 1, 1 plus 1 z inverse plus half z inverse is nothing but when you add this 3 by 2 z inverse, middle term will be. Then when you multiply this z inverse into 1 by 2 z inverse, you get 1 by 2 z inverse minus. Then that is how you do in maths also factorizations. Then after this what? Write x1z is equal to k1 of this plus k2 by this partial fractions. Find out, solve k1 k2, you get k1 k2. Like my previous sessions. For example, k1 is equal to neglect k2. Write x1z into 1 plus z inverse. At z is equal to minus 1. See this. Why? Because here is plus 1 is here. Till now I should get 1 minus half minus something. 1 minus 1 here, since it is plus 1 is there. Here this can be written as 1 minus half minus 1 z inverse. Now such a way you should choose here is z is equal to this minus 1. You should get minus term only. Right? Therefore z is equal to minus 1. Then apply. You will get 1 plus z inverse by 1 by x on z is nothing but 1 by 1 plus z inverse, 1 plus 1 by 2 z inverse. At z is equal to minus 1. Now substitute wherever z is there, minus 1. Now for example, this is the equation, this gets cancelled. This is the equation 1 plus 1 by 2, minus 1 to the power z is minus 1 to the power 1 minus 1. That is nothing but after simplification 1 by 1 minus 1 by 2, which is nothing but 1 by 2. That is equal to 2. K is 2. Similarly, solve K2. K2 means neglect K1. Neglect this K1 terms. K2 is equal to 1 plus 1 by 2 z inverse into x1z. That's what I am writing. K2 is equal to 1 plus 1 by 2 z inverse x1z. At z is equal to same. It is 1 minus half minus 1 by 2, right? Then z is equal to that minus. Right? Now substitute and you will get K2. 1 plus 1 by 2 z inverse by 1 by 1 plus z inverse. 1 plus 1 by 2 z inverse. At z is equal to minus 1 by 2. Substitute minus z. This gets cancelled. This is equation 1 plus. What is that? Z is minus 1 by 2 inverse. That is equal to when you substitute. When you do this maths, 1 minus 1 to the power minus 1. Then 2 to the power minus 1. Then this can be simplified as 1 minus half. Minus 1 to the power 100 is also minus 1. Right? Whatever is there, this only will give minus of 100. Right? Now, into 2. This is 2 to the power minus 1 goes out, then 2 to the power plus 1, which is nothing but 1 by 1 minus 2, which is equal to minus 1. Therefore, K2 is minus 1. Now substitute all that. X of z is equal to z inverse plus, what is x1z? This is 2 by 1 plus z inverse plus minus 1 by 1 plus 1 by 2 z inverse. Call it as equation number star. Now, go to your final, alright, the last conclusions to get x of n. Since what is given in the problem? Since z part z is less than 1 by 2, problem only is given. ROC is given in the problem. This is the way ROC division of convergence is given in the problem. Then what you will understand? Therefore, since it is inside, ROC is coming exist inside circle. Therefore, x of n must be, both must be not right sided. It is left sided signals. It is left sided signals. ROC is exactly coming inside this 1 by 2, right? Therefore, this must be left sided signal. right? This must be left-sided signals. Now, therefore, in the end, by using inverse transform formula standard and linear property, because A1, A2 exists, A1 is 2, A2 is minus 1, we get IZT of x of z as x of z. IZT of x of z is x of n, original sequence. IZT of z power minus 1 is delta of n minus 1, which is there in the standard formula. That is shown here. That is shown here. For example, IZT, we know that the transform of shifted functions delta n shifted by minus p, you will be having z power minus 1. Similarly, if you take inverse z transform of z power minus p, in this case is minus 1 is there. Delta of n minus 1 is there. That is how you are writing n minus 1. Plus, here this 2 is linear property. A 2 into 1 by 1 plus z inverse IZT is actually you have to write 1 by 1 minus of minus 1 z power minus 1. Then that is inverse z transform is actually minus of this 1 is there, minus 1 to the power n u of minus n minus 1, because left sided sequence this is, because R1 is given inside a circle. Similarly, second one, this also minus 1 is your minus 1 is your what is that? This constant, and the z transform of 1 by 1 minus of minus 1 by 2 z inverse is standard is equal to minus formula is there, minus of minus 1 by 2 to the power n u of minus n minus 1, because left sided sequence. Now these two are given here, standard equations. I know z transform of u of minus n minus 1 from this table, you look the table, minus alpha to the power n instead of alpha 1 by 2 I am adding there, is equal to 1 by 1 minus alpha z inverse if mod z is less than 1, that means left side sequence. In this case it is left side sequence given, right? Here minus sign is here, that's what I am writing. See this minus sign, minus sign, right? Then in the end, simplify x of n delta of original sequence is equal to delta of n minus 1. This is minus into plus is minus 2 minus 1 to the power n u of minus n minus 1. This is left sided sequence 1. Then here also minus 1 minus plus minus 1 by 2 to the power n u of minus n minus 1. This is how we can get original signal x of n, complex signal. This is from complex process x of z. X of z is this. Complex process x of z is big X of z. Big X of z. This is right. In your processing, always they will give you complex, right? You will be having complex signals only. You will not have simple signals like u of n, u of minus n. No. In your today's processing, multi-processing, you know how many users are using today? Zoom. We are all connecting in this corona period. We are all discussing better than the previous manual discussions through a Zoom or through online. Then definitely 1,000 times you will get complex signal processing only. It is not a simple signal processing, and you will always get this type of signal only, right? n is equal to 3, n is equal to 2 line. Now let me quickly repeat now within 2 minutes. First we will give you expressions like this. Then you first check the maximum powers. Then multiply by z power minus 3. Then you will get like this. Multiply by minus 3. You will get normal expressions. 1 plus of z power minus expressions. 1 plus of z power minus expressions. Then see the powers of m and n. M is 3, n is 2. Therefore, it is coming under long division method only. I know this method. Write denominator as the divisor, numerator as dividend. Start dividing with a term such a way that z power minus 1. This gets cancelled, so we get plus 1. Now write x of z, bring it to normal form. Remainder you first write, quotient you write first, z power minus 1 plus 1 by remainder by this divisions. You will get x1z. Now take this out. Then solve for like your normal expressions. 1 by this, then 1 by calculation, k1, k2, solve k1 and k2. k1 is equal to, this is minus 1. See this would be minus 1. Then k1 is equal to minus 1 and k. Similarly, solve for k2. you will get K2 is equal to the value as -1. Then substitute in the complex Z transform, Z power -1, all these things, call it as star, then apply conditions, get the original signal x of n, which is nothing but this delta of n minus 1 plus 2 because linear. Then this is from the table, this is u minus 1 minus 1 minus of -1 to the power n. Similarly, second term, in the end you will get complex original signal x of n. And this is how, right, and this is the formula that I used from the table, I have substituted, right. This is how we can get, right, we can use a YZT in what is that inverse Z transform technique of m greater than n to get my original sequence x of n, which is very, very important, which is not there. This type of flexible, effective, efficient method is not there to analyze, right, discrete time signals, which is what today is processing, right. That is why this is very, very easy, right, and very, very important actually to anybody to design or to increase, to design filters and to increase the speed of the processors, right. I hope I am clear. In the next class, I am going to give you, right, the basics of what is it, the problems, right, with respect to power series method, how to get back original signals using one more technique called power series method. Till that, right, I hope I am clear. Wait for that sessions. And till that, right, thank you very much, right, for a patience listening. Right, bye.